Hey there, I'm Flora Lichtman, and you are listening to Science Friday. Today in the podcast, a revolution in weather forecasting and one of the scientists behind it.
We have much more confidence in a prediction of climate 100 years from now than we have in 100 days weather.
Nowadays, the weather is right at our fingertips. It's definitely one of my most visited apps, but until about 40 years ago, scientists couldn't forecast the weather beyond 10 days, and that means they couldn't predict seasonal patterns. So you couldn't know how hot it was going to get in the summer or how much snow to expect in the winter, and without that, you can't plan for things like wildfires, droughts, or hurricanes. But climate scientist Jagadish Shukla, who grew up in a village in rural India and saw how people's lives depended on this information, made it his mission to forecast seasonal weather events. And in doing so, he changed the course of modern weather prediction. He tells the story in his new book, A Billion Butterflies, A Life in Climate and Chaos Theory. He's a distinguished professor at George Mason University in Fairfax, Virginia, and he was one of the lead authors on the 2007 report of the Intergovernmental Panel on Climate Change, which was awarded a Nobel Peace Prize. Shukla, welcome to Science Friday.
Thank you.
Let's start in the present. How good are we at predicting the weather today?
I think that our 3-day, 5-day forecasts are really pretty good. 30 years ago, we will not put much stock in the actual forecast 5 days ahead. So thanks to this revolution in computing, in getting better models, getting a lot of observations from satellites, I think the weather prediction has been steadily improving. And up to 7 days, it's pretty good. But then it gets a little bit tricky after 10 days. Some people feel that even 15 days we can say something about.
So it gets tricky at 10 or 15 days. Do you think that will change, or is there a limit to how much we can know?
That's a very good question. That's the origin of the whole word butterfly effect. And the Professor Lorentz at MIT, who was one of my advisors, he showed that no matter how good models we have, the nature of equations which predict the weather are such that even a small error in the initial condition can actually make the forecasts not very useful as time goes further. And he used the butterfly effect to say that as small as the flutter of a butterfly wings. So now there will be a limit of making weather prediction. But to make clear that we understand the difference between weather prediction and seasonal prediction and climate prediction. These are three different problems, and the processes are very different.
Yes. What is the difference between weather prediction and sort of seasonal weather pattern prediction or seasonal prediction?
So the weather prediction is you start from today's initial conditions of the global weather, and you try to predict every 3 minutes what will happen after 3 minutes, then 6 minutes, then 9 minutes, and then up to 24 hours, and then up to 10 days. That's why we need supercomputers. And then you are giving a very detailed structure of weather. However, this breaks down after about 2 weeks. 10 days becomes not very useful, but completely breaks down. What is meant by breakdown? It means your forecast will not be any different than if randomly I picked up a map.
We know what it means to break down. We've all lived it because we've planned on the 14-day forecast and it didn't turn out that way.
Exactly. But believe me, we're trying to cross that barrier. Seasonal prediction is, on the other hand, predicting what will happen to the seasonal mean conditions. Will there be a rainy season, a drought season? The real sort of contribution that came in my work was to recognize that the prediction of seasonal mean does not depend upon the initial conditions.
It sounds like we can't do weather past 14 days, but we can do seasonal weather patterns. Right. Like, will there be a monsoon or won't there be?
And weather prediction means we're predicting day by day, the actual sequence. Today, tomorrow, day after tomorrow, 12 hours later, up to 10 days. In seasonal prediction, you are predicting average of seasonal conditions. June, July, August average. DJF, March, April, May, that's where we use. Because when you say butterfly effect cannot predict weather, what we really mean is that we cannot predict the sequence correctly. In seasonal prediction, the reason it is predictable is because now you don't have to worry about exact sequence so long as you can predict the average. And the average depends upon the boundary conditions like ocean temperature and land.
Well, I was going to ask, does climate change make predicting the weather or these seasonal changes harder?
It makes actually these seasonal changes and weather makes the climate prediction harder. We really have tried to convey to people that we have much more confidence in a prediction of climate 100 years from now than we have in 100 days weather. Why?
It's amazing. Yeah.
Why? Because the climate change does not depend upon small ocean and atmosphere and land interactions. It depends upon what we call external forcing. There are three external forcing, either sun or volcanoes or amount of carbon dioxide we put in the atmosphere. So sun and volcanoes haven't done much at all, but the amount of carbon dioxide we are putting in the atmosphere is really very important in determining what will happen. So that's why if we know the carbon dioxide, we can tell you the climate with a lot of confidence.
I want to talk about current events. We know that federal cuts are affecting NOAA and the National Weather Service. There was news out last week that weather forecasting offices have to cut back on some data collection. What do you make of that? Are you concerned about that?
I mean, you'll have to stop me once I go on this, okay? It is so uncertain what is going to happen next. It is just devastating what is happening about the future of weather and climate prediction. I mean, how to get better. And in fact, it will start getting worse. More people will die. More property will be lost. This is something we can predict without a model. And I think that many of the weather and climate scientists, and I have to include myself, we are losing sleep over where is this field going.
Don't go away. After the break, Dr. Shukla's childhood in India and how that led him to his life in science.
Monsoon affects every aspect of life. It affects music. It affects culture. Of course, it affects agriculture production.
Stay with us. Science Friday is supported by Factor. In my house, as summertime ramps up, the schedule goes out the window. In a good way. There's vacations and summer camps with weird hours, extended playground hangs to take advantage of those long summer days. But that means that meal planning can take a hit. Well, Factor is here to help. Thanks to the menus crafted by chefs, Factor offers fresh, never frozen meals. They're dietitian approved and ready to eat in just 2 minutes. You can feel nourished and ready to roll no matter what life throws at you. Perfect for any busy lifestyle with 40 options across 8 dietary preferences on the menu each week. It's easy to pick meals that are tailored to your eating goals. If you're a smoothie person, they've got that. A breakfast grab and go person, they've got that. Keto, calorie smart, protein, many other options. Eat smart with Factor. Get started at factormeals.com/factorpodcast and use the code FRIDAY50OFF to get 50% off your first box plus free shipping. That's factormeals.com/factorpodcast with the code FRIDAY50OFF to get 50% off plus free shipping on your first box.
WNYC Studios is supported by Earth Justice. As a national legal nonprofit, Earth Justice has more than 200 full-time lawyers who fight for a healthy environment. They wield the power of the law to protect people's health, preserve magnificent places and wildlife, and advance clean energy to combat climate change. Earth Justice fights in court because the earth needs a good lawyer. Learn more at earthjustice.org.
This episode is brought to you by Progressive Commercial Insurance. Trucking is a big job, so Progressive is proud to offer truckers the coverage they need and discounts to help them save. Quote truck insurance in as little as 7 minutes at progressivecommercial.com. Progressive Casualty Insurance Company and Affiliates. Discounts not available in all states or situations.
Support for Science Friday comes from the Alfred P. Sloan Foundation, working to enhance public understanding of science, technology, and economics in the modern world.
I want to talk about how we got here. So when you started your career, it sounds like there was this idea that you could not actually predict seasonal patterns.
Yes.
Is that right?
Yes.
And this was the butterfly theory that had been sort of extrapolated out, right? It was the idea that there's too many variables. A tiny butterfly flapping its wings would, create profound impacts. We could never understand a pattern. But you were like, I don't buy that. I don't think that's true.
Let me tell you why. So I had experience in my own life that in Indian monsoon, when there is a drought and everybody is suffering, when there is a good monsoon year, there's a lot of rainfall, there's a lot of harvest and so on. So if something is happening for the whole season and something is happening for the whole country of this scale, I just was not prepared to believe that a few butterflies can change that, if I want to use that word, okay? And so, of course, my biggest challenge was first, so I come to MIT with this idea. And then I found out that the father of butterfly effect is a professor there, and he's one of my advisors. I told my advisors that this is what I want to work. And, they both fully supported my idea. And they said, look, we never said that seasonal predictions are not predictable. People interpreted that to mean that it's not predictable.
Interesting.
So you just show me. So I said, so I launched a whole set of experiments and studies and showed, and one of the experiments is what I call billion butterfly experiment, is that, hey, I can show a condition where I change the initial conditions as if there were a billion butterflies who were flapping their wings. Or billions of fish were changing the ocean, whatever, and then showed that nothing happened into the atmosphere. Why? It was because the ocean temperature I had kept same in both of them.
Got it.
And
that was the biggest factor.
That was the biggest factor. And when the result came, that gave me the confidence to say that, there is predictability in the midst of chaos, because now I was demonstrating that using the same language that the butterfly effect was used to show whether it's not predictable.
I want to ask you about this, the personal side of this, because I read this in your book, and you're studying at MIT. You're junior at this point. There's a prevailing theory that everyone basically takes as gospel, and you're like, I don't think so. Where did you get the guts to do that?
I have been asked this question many times. And this is not the only instance. There have been many other instances. One of them being my great professor. When I met him first time in Tokyo in a meeting, I started arguing with him. And everybody in the audience thought this kid from India is crazy. I was 24-year-old, and he was the world's most famous meteorologist. At the end of the conversation, he actually came to my table and he said, I want to talk to you. That's how I came to MIT. So
really,
I think I have told you as before, it was a philosophical feeling that there has to be predictability. You cannot have millions, hundreds of millions of people's life depend upon seasonal wind prediction and nature saying, no, it's not predictable. So I have written in my book, I think that I had no deep knowledge. In fact, I had no knowledge of butterfly effect. As a matter of fact, some people claim that if you knew it, you would not have made such a stupid proposal. But I didn't know it, and then I ended up going to prove it.
But I mean, you believed in your point of view, your philosophical point of view, but what gave you the confidence to believe in yourself?
The observation that monsoon droughts persist for the whole season. The observations that droughts are over whole India. Such large-scale persistent phenomena in nature is not weather, is not going to be, and there has to be some predictability in it. There has to be. So that part is religious, you can say, that God cannot be so cruel, right, to millions of humanity.
Tell me about where you grew up.
So I grew up in a very small village, no electricity, no road, no transportation. I walked barefoot till I was 12 or 14 to my middle school and high school. And but somehow my father really wanted me to study science, except that there was no science school anywhere near the village. So anyway, he finds a way. He gives me all the books for 6 years. You read this, and there will be a test, and then I pass the test. So I moved to the science.
How did monsoons, these seasonal weather patterns, affect life where you lived?
Monsoon affects every aspect of life. It affects music. It affects culture. Of course, it affects agriculture production. And agriculture is where the largest fraction of Indian population works. It's only now, in the last 15, 20 years, that you are slowly getting, other areas. So, no, monsoon is a very integral part that influence every fabric of Indian society.
And what was it like in your village when the rains came?
There is just, people just look at the clouds and say, oh my God, the rain has come. Everybody starts running and dancing and get prepared to put the seeds, the rice seeds. And imagine if there's a drought, then it's a big problem.
And I'm guessing that the uncertainty about when those rains would come, if they would come, must have been existential.
Absolutely, because the only thing they knew is the seasonal cycle. It comes sometime in the end of June, sometimes, but which day, which week which will come? No. And it's so devastating where sometimes they say, oh, maybe there are clouds, it will come, they go and plow, and then it doesn't come. And I think that it's changing now. It has completely changed because we have these forecasts with models and there is a system to inform people.
And how does that manifest? What happens differently now?
Well, it's different because they plant their seeds. They will know, just because they see a rain, it doesn't mean they will jump into the fields. They will know, there will be a forecast that is it going to be a sustained rain or it will be temporary rain. If it's going to be very hot. And people are also changing the seeds. Now, you can take advantage of these weather forecasts to maximize the yield into the agricultural yield.
Your scientific career has been about, finding predictability in the chaos. Do you try to do that with your own life to try to understand your own, unpredictable story?
If you look at the title of my book, A Life in Climate and Chaos, is just exactly that means because, and if you read the book, it is basically runs parallel chaos in my life and chaos in climate system. It goes on. I really wanted to do this because there are millions and millions of children in the villages, and I wanted them to know it is possible to be able to actually contribute, do things, even if you are in this very challenging situation. And it somehow comes out fine at the end. That's why you are interviewing me, probably.
To bring it back to the butterfly effect, do you think that if you weren't born and raised in this village in India where the monsoons were so important, do you think you would still be a climate scientist?
Oh, no. I it's hard to predict, certainly going backwards, but I always say, by the way, it's luck. I was the beneficiary of good luck and serendipity. Things just happened. I go to Government of India sends me to Tokyo, and whom I met, the greatest meteorologist in the world.
What's that adage? Luck favors the prepared mind?
Oh, yeah, I have heard that. I don't remember exactly, but you are right. Luck just gives you the opportunity, but then you do something to take advantage of that opportunity.
Can I ask you to get a little philosophical with us? Finding predictability in chaos feels like a useful mantra for these times. How do you suggest we apply that to our lives? Do you have any sort of life lesson that relates to that?
Well, I will give you a small examples. One of my sort of philosophies has been never give up. And if you read the book, you will find that I have paid price for speaking out, for doing things, particularly about climate change. And I feel the same way now. When I teach my students, they say, we have so much climate anxiety. And I said, solution to the climate anxiety is climate action. Get engaged, get involved, find other students, make a community. You have to fight injustice. You cannot just give up. In the end of the day, either we succeed, but at least we feel we have done something. I think you'll see my book is dedicated to 3 of my grandchildren. I wanted them to know that I just don't talk about the climate change, but I try to do something about it because I'm concerned about their future. They're the one who are going to get the brunt of the climate impacts. They're the one who need to adapt to it. So I have always remained very upbeat and positive in facing these problems. Although I have been hit hard and knocked down a few times, but I feel in the end, it gives you much more pleasure just to have tried and failed, as the saying goes, rather than not tried.
I think that's the perfect place to leave it. Shukla, thank you so much for joining me today.
Oh, thank you. Thank you very much.
Dr. Jagadish Shukla is the author of 1 Billion Butterflies, A Life in Climate and Chaos Theory. And that is about all we have time for. Lots of folks helped make this show happen, including
D. Peterschmidt,
Fraser Gucci,
Kathleen Davis,
Santiago Flores.
I'm Flora Lichtman. Thanks for listening.